Bien, nous allons commencer. Bienvenue à tous pour ce webinaire orienté aujourd'hui sur les technologies de programmation dans le cadre d'application et de fabrication pour les white goods. Avant de commencer ce webinaire, quelques informations. Donc, je suis Frédéric Maraval, je suis le responsable produit au sein de Visit, et ce webinaire est fait en commun avec notre partenaire SMH, et je serai assisté aujourd'hui par Yvan Liberotti qui vous fera la principale présentation et que je remercie de m'accompagner aujourd'hui. Comme je disais avant de démarrer, des informations sur le déroulé de la session. Donc, ce webinaire sera enregistré. L'enregistrement et le replay sera disponible et partagé à la fin de la session dès qu'on aura réalisé le montage. Durant toute la session, les micros des participants seront coupés, mais vous pouvez à tout instant communiquer avec nous à travers le chat questions que vous pourrez utiliser pour la session de Q&A en fin de webinaire, mais n'hésitez pas d'interagir durant toute la présentation. Petite astuce, notez éventuellement s'il y a des questions spécifiques à certaines parties de la présentation et de slide, de noter le numéro de la slide concernée. Ça permet d'être un petit peu plus rapide et précis dans les réponses. Et à la fin de ce webinaire, vous recevrez un petit questionnaire de 3-4 questions qui nous permet de faire évoluer nos événements de ce type et les améliorer. Donc je vous remercie par avance de vos réponses et du temps que vous consacrez pour ce petit sondage. Alors pourquoi ce webinaire aujourd'hui et pourquoi on parle du contexte de la programmation et sur les chaînes de production? En fait, c'est lié à, depuis quelques années, l'évolution des cartes électroniques et notamment de leur complexité, les performances des cartes concernées, qui amène beaucoup de nouveaux défis à relever dans le cadre de la fabrication et de la production. Entre autres, comment allier et faire le compromis à des cadences de production de plus en plus élevées, mais tout en garantissant la qualité ainsi que la robustesse de cette production. Également, l'évolution des lignes de production et les problématiques d'intégration qu'il peut y avoir justement des systèmes de programmation des composants sur les lignes, et quelles seraient les solutions ou les méthodologies les plus optimum par rapport à son cas particulier pour chaque ligne de production. Et des nouveaux risques qui sont apparus depuis quelque temps maintenant, mais qui font vraiment aujourd'hui évoluer les process, et tout ce qui concerne la cybersécurité, comment protéger son IP durant ces phases-là de fabrication et de programmation de composants, notamment si ce sont des activités qui sont sous-traitées, ou comment assurer là aussi que durant ces phases, il n'y ait pas de backdoor qui soit introduite ou de modification. Voilà les nouveaux enjeux qui sont apparus ces dernières années. Alors, qu'amènent les solutions SMH dans ce domaine? Eh bien, je vais laisser pour ça la main à Yvan qui va vous faire sa présentation et vous amener des éléments de réponse sur ces différents points. Yvan, it is up to you. You should have the end now for doing your presentation.
Perfect, thank you. Good morning, everybody. I will share my screen now and start with the presentation. So, I think you can see my screen now. From this presentation, we will touch these points listed in this first slide. So, at the beginning, I will give you a general overview about the company and about the products that we are offering to the market in order to cover the industrial production and environments. After that, I will talk about the how to manage our products in production lines, and then we will also spend a lot of words about cybersecurity concern to protect how SMH is handling this demanding topic nowadays. So first of all, SMH technology is market leader in providing programming system solutions. We continue to invest in new ISP technology worldwide, and we are in collaboration with a net of players in this field that is worldwide, such as EasyIt, for example, is one of our technological partners. What we provide to our customer is both hardware and software to flash microcontrollers and any kind of components that has a memory inside in industrial environments production lines. So we are highly focused in providing this kind of solutions. We started from being debugger for ST microelectronics and other silicon producer, and with the evolution of this market, we started to manufacture a complete programming system to ease the concern of integrating a flashing solution in big automatized production lines, industrial environments. This is one of our products called FlashRunner 2.0. In this case, we have a picture of the FlashRunner 2.0 16 channel, and from here you can see how you can connect it to a PC through the USB cable or through the LAN cable. And on the top you can see the in-system programming connector, which is actually the connector that allows you to program your target devices. This is another product of our FlashRunner 2.0 line called FlashRunner HS High Speed. In particular, this picture is showing the control unit of the FlashRunner HS, which has a different concept of programming from the FlashRunner 2.0, but we will talk about this later. From here you can see that the interfaces to connect the programmer to a PC are the same, USB and Ethernet LAN, and on both programmers we have also a way to control it in a standalone way. Okay, what are the important characteristics of FlashRunner that allows us to be in the market from so many years in industrial environments and production lines? The fact that FlashRunner is designed to work 24/7, and it is a really reliable and robust solution. We have a device list of more than 10,000 devices at the moment, and we are focused in providing production efficiency solutions, production efficiency oriented solutions. This is a slide that is showing the flexibility of all our products. And this is very explicative about how you can configure your solution in order to fit your needs, your production. So on the top of the slide, you can see the FlashRunner NXG, which reaches up to 4 channels. All our products are parallel programmers, so they provide more than one ISP connector to connect to your targets. And you can program your ISP target in parallel. So the NXG provides flexibility of up to 4 channels. We have FlashRunner 2.0 here that can be seen in 2 versions, 8 channel and 16 channel. And then we have the FlashRunner HS that, as I was saying before, has a different concept of programming. Basically, here we have a control unit which has 8 links, from where 8 USB Type-C cables are coming out from this picture, but of course you can configure the hardware to use more or less links. And these links are directly plugged into through a USB Type-C cable that can be 6 meters, up to 6 meters long. It is connected to active modules, the object you see at the end of the Type-C cable. These active modules are actually the objects that are performing the flashing of the microcontrollers or other components, differently from what was happening in the predecessor solutions. These active modules are specialized in flashing different architectures, from microcontrollers to eMMCs to NAND memories, and we have also active modules that are specialized to perform end-of-line protocols such as CAN protocol and so on. We will talk about this later. This configuration can reach up to 32 channels in parallel. Another important aspect of our platforms is that FlashRunner 2.0 is universal. So we are not bounded to any silicon producer. We can program every kind of microcontrollers coming out from every silicon producer, whatever the communication protocol would be. It means that even we of course support the most common protocols in the market, like JTAG, FWD, UART, I2C, SPI, and so on. But we are also covering the proprietary protocols developed by the silicon producer in order to program particular microcontroller. What we aim is, of course, the production efficiency, is to provide to our customer the most performance solution in the production environment, which is also cost effective. And we do this by providing hardware and software that are focused in reaching these objects you see in this slide: fast programming speed, channel parallelism, and then we have also added cybersecurity features, both the target side and FlashRunner side, because nowadays the sectors in which we work are becoming more and more demanding from this point of view. As you can see, the design of the products is really compact, and it is easy to integrate them inside industrial environments or production line. Here you have a recap of the active modules that can be connected to the control unit. So we have a GP4 active module that allows you to program the most common microcontrollers in the market that are using the JTAG, SWD, and this kind of protocol interfaces to be programmed. eMMC active modules, NAND, CAN, Octal SPI active modules. So you can see that they are specialized for their own functionality. Here we have other three active modules that are used to program, for example, UFS storage memories, USB active module that is using the USB interface to connect to a microprocessor and program different memories connected to these microprocessors, and also automotive Ethernet active module. A particular focus is on the CAN module, which is the object that is allowed to perform these end-of-line protocols, diagnostic protocol, for doing also functional testing more than flashing. So now we are giving you a general overview about what we developed in collaboration with these two big companies to actually integrate this hardware in your system. So we developed collaboration with VPC and ODU in order to develop solutions to integrate our platform in your production lines. These are our products, which are using the pieces provided by VPC, which are basically high performance mass interconnection that allows you to keep stability and integrity on the signal, even going up with the frequency. So we developed this object. You can see here the Type-C cables that are used to interface the FlashRunner HS, for example, into your production system. This is an example of how you can integrate FlashRunner HS into your production lines. Here you can see the VPC object in the middle, one part machinery side and one part inside the fixture. You can see the control unit plugged to this object through USB Type-C cable, and you can see inside the fixture, the active module which have their own ISP connector on the other side of the Type-C cable. The ISP connector is the same connector you saw at the beginning here, that allows you to connect to your target device. Of course, we thought about this solution to place this object, the active modules, really close to the target, so that the wiring from the ISP connector to the target could be really short, in order to increase the frequency of the communication protocol and lower down the cycle time of the flashing. Okay. Here there's another example by directly plugging the object into the control unit without having the Type-C USB cable in the middle. And here there's the solution developed with ODU, which serves the same purposes of the object developed with VPC. Here you can see an example of integration with the ODU. And this is a very relevant slide, in my opinion, which explains to you actually what you need to put inside the fixture and what you need to put machinery side for a well-done integration. Basically, there are active modules like GP4 here in the picture that doesn't really need an high frequency to program the microcontrollers. So they don't need to be placed really close to the target to be more performant. Actually, the active modules that needs to be put inside the fixture really close to the target are the active modules that are simulating the protocols that really benefits from increasing the frequency. And these active modules are basically the ones that are programming huge size memories like eMMC, octal SPI memory, and so on. What does this mean? Basically, when you are placing, for example, an eMMC active module inside the fixture really close to the target, you should have a really short wiring from the ISP connector to the eMMC, and you can extremely increase the communication frequency that reaches the target. And in this way, you are extremely lowering down the flashing time to program your target device. So here you can see an example of an hybrid solution in which some active modules are put inside the fixture, the one that really benefits from increasing the frequency, and some active modules put outside the fixture, the ones that are basically designed to simulate the JTAG protocol, SWD protocol that does not really benefit from increasing the frequency at high levels. Okay. Here is an example of the pylon block that you can use to interface the GP4 machinery side inside the fixer to the inner side of the fixer. And this is another collaboration we developed with VPC, a project that is involving the FlashRunner pseudo-08 channel with the relay barrier integrated. So this is another project we are working on together with VPC. FlashRunner HS Compact is another solution that is actually mixing the benefits that you can gain from HS and you can gain from 2.0. What I mean is that maybe, as you can imagine, the FlashRunner 2.0, the one in this picture here for example, this one, once it is configured to program microcontrollers, you cannot mix eMMC architectures. You cannot mix really different architectures. Instead, with FlashRunner HS, you can actually put one link used to program the general purpose microcontroller, one link with an eMMC active module used to program eMMC, and so on. So you can actually mix with this solution different architectures. What thing that you couldn't do with the FlashRunner 2.0? The FlashRunner HS Compact is basically mixing the two technology and giving a solution to integrate the FlashRunner HS as a FlashRunner 2.0, but with also the advantage of mixing different architectures such as EMCs, microcontrollers, CAN modules, and so on. Now let's talk about some software features that we provide to our customer in order to handle our platforms. So what you have to know is that there are 5 main parts that are part of our ecosystem. The graphical user interface, called also Workbench, that you can download free from our website. And this is basically a development and test phase and test tool during this development phase. So basically, when you are trying our products with your ISP target, you can use the graphical user interface to handle programming, flashing, creating new project, flashing resources, in order to allow FlashRunner 2.0 to correctly interface to your target device. Then we have the drivers, so-called, that are basically the flashing algorithms that are running inside the FlashRunner in order to program your target devices. We have a Linux distribution, like Linux distribution running on our microprocessor, basically the operating system of the FlashRunner, which is making it work same as a PC, basically. And then we have the already mentioned project, which is basically a text file that you can create through our graphical user interface, and that is the resemble of the instruction that you can launch to the programmer, and that allows you to perform operation on the target device. And then we have this file, the devices.smh, which is a collector of our database. So basically, we have a huge database. As I was saying, in this database there are more than 15,000 devices. All the information about these devices are collected into this file. And this file is loaded by the graphical user interface at the beginning when you are launching it, in order to provide to our customer all the library of our devices and create project to manage your device. How they cooperate together. So as I was saying, during a developing phase, during a test phase, when you are in your bench and you want to test our solution, you can use the graphical user interface, which is a Windows or Linux application. At the beginning, it is loading. When you launch it, it is loading our database inside of it. And then, from that point on, you can build your project that are the collector of the instruction you want to perform to our target, and the FRB. This is basically a FlashRunner binary, an acronym for FlashRunner binary, and it is the conversion of your source firmware file saved into usually Intel X format, Motorola SREC format, raw binary format. So what FlashRunner is handling is actually a FlashRunner binary file, which is the conversion of your source firmware file. I think at this moment we can show something from the graphical user interface without losing words on what are these tools. I will just go through the graphical user interface and show you here. So basically this is how our graphical user interface comes to you when you are downloading it free from our website. And for example, I have a project here. I'm not gonna say much details, but I'm gonna show you the how powerful is this tool. So from here we have the pin map tool that allows you to select the platform and allows you to see what are actually the connections that you have to perform for this particular protocol to the target from the ISP connector we saw before. So selecting, for example, CAN protocol, you see you have to connect here. Selecting SWD channel 5, you have to connect here. Ground lines, VPROC 0 lines, and data lines here. And it is the list here. Usually, digital input-output stands for FlashRunner pin, and reset, SWD clock, and SWDIO stands for the pins of the microcontroller you should connect our channel to. Then we have also a memory map tool, which is showing you the memories that the FlashRunner is actually supporting for this particular microcontroller. Okay. And then we have the file manager tool. So a very important thing to know is that FlashRunner has an SD card inside, which is storing all the information that it needs to program the target devices. These information are the project, as I was saying, the flashing algorithms, the FlashRunner binary, and the licenses to run your target device. So when you are testing in the bench the FlashRunner with your solution, you can upload project, flashing algorithms, binary files, and so on. But then you can keep in mind that these are stored inside the FlashRunner, and when moving to a production line, you can automatize the process by launching, without using a graphical user interface or a PC, the project which are inside the SD card. So once they are inside, you can use them without being connected to any kind of stuff. Okay. So you don't need to upload all the time the project, the algorithms, they are already stored inside the FlashRunner in its SD card. We have the real-time log here that is showing you in real time what operation you are performing to the target. We have also a log stored inside the SD card that you can fetch from in order to see what operation has been done in the past and so on. And we have also the button, of course, to create your project. It is very easy to create the project. And I want to point out something from here, that is the conversion from your source file into an FRB file. So let's choose, for example, a device here, and let's go into the advanced FRB setup. So basically, here you can create your own FlashRunner binary file by starting from your source firmware file. Usually a firmware file comes into these three formats that are the most common in the market. Okay. But we are also supporting proprietary format that are visible only when selecting these kind of devices that need them. Basically, Renesas devices, sometimes they have RPI format. Infineon devices, they have AHEX format. So those options will come up when you are actually selecting a device that have that option available. So for now, let's just focus on these three that maybe you are familiar with. Let's upload a binary file, for example. Okay, and here you can see that the line is green. Green means that the binary file you uploaded fits in the memory map of the device. In fact, we uploaded a 2 megabyte binary file into an 8 megabyte memory. Okay, once you click next, you have your source firmware file here, and this is the output file that will be managed by FlashRunner in order to program your target device. And then you can also have a conversion report saved in your PC, which is basically showing you the results of the conversion if something is not clear and so on. Here you have some settings about the protocols, about the power supply. Another important thing is that FlashRunner 2.0 together with FlashRunner HS, can provide supply to your target devices. Every channel has 2 pins that are used for this purpose, VPROG 0 pin and VPROG 1 pin. VPROG 0 goes from 1.8 volts to 5.5 volts, and it is used to supply just the microcontroller, so just the components that you want to program. In fact, the range of voltages is suited for that purpose. The VPROG 1 pin instead goes from 6.5 volts to 13.5 volts, and that is used to supply the whole board. So basically you can give VBAT, for example, which is 12 volts, around 12 volts, 13 volts. You can actually use the VPROG 1 pin to supply the whole board. One important thing to keep in mind is that we have some current consumption restriction. So basically, if the board is consuming more than 200 milliampere, we do not recommend to use the VPROG 1 pin, but we recommend to use an external power supply. And then we have some additional parameters and additional commands that are basically particular for the device that you chose, and that are explained both these ones and these ones here, which are like commands that are different from the standard one, erasing the memory, program the memory, checking the memory. They are some particular commands. They are explained in the wiki section of our website. Okay, so in this way, it is very simple to create a project and then run your project to test your device. Here there's a button that shows you the our device library. Okay, and it is also visible in our website. Okay, I think we can go on with the presentation. So I show you now the graphical user interface, and I remarked that this is a tool to be used when you are testing your solution in a bench and so on. What do we provide for a production line for industrial environments? We substitute the workbench functionality with DLLs and command line tools that are objects that are that allows our customer to automate their production line, their industrial environments. They can be used to execute project, but also run single commands inside the project. Maybe I forgot to show that this is actually a project, and as you can see, it is done by some parts. We have an application note that is explaining what are these parts, and here in the green part you can see the operation that we do to the target devices and the parameters that we are setting to correctly program the target device. These single lines can be sent through DLL, but also the whole project can be run through DLL. So it is a very versatile solution to automatize your production line. They are developed in C, C++, and C#, and they can be easily integrated into some NI environments such as TestEnd or LabVIEW. We have also an application note that is explaining how to do that. And same applies to command line tools that maybe you're more familiar with. Some command line tool to transfer data to the FlashRunner, get data from it, send commands, or also converting your firmware files into FRB. And this is how they cooperate together. Basically, it is the same, but we substitute the graphical user interface with the DLLs. We still have an operating system that is commanded by the DLLs, which is interacting continuously with our flashing algorithm to perform the instruction coming out from the project. So when the DLLs is running the project and the project is saying program, the operating system is sending to the flashing algorithm the program command, and the flashing algorithm will program your target device with the FRB you created from your input file. About FlashRunner 2.0, we have some hardware tools here that allows you to integrate and have a more complex solution for your production line, which are the three listed here. The relay barrier, which is providing galvanic isolation to your target devices. So basically you are detaching the ISP lines connected from the target to the FlashRunner, and this is very useful when you are also performing functional tests, ICT, and so on. You are guaranteed that FlashRunner is not connected to your device in any ways. The demultiplexer is used to double the output lines of the input lines of the platform you connected here. For example, here there is the 16-channel demultiplexer, but we also have the 8-channel version. So basically, you are having in output 32 connectors to program 32 targets in parallel. Not in parallel, sorry. You must keep in mind that is still 16 lines in parallel and then another row of 16 lines. So basically you are doing a series programming, but you still have double the lines in output. And then we have also the cable interface together with the flat cables and header provided by SMH, which improves and guarantees signal integrity and stability. What is the point of these tools, this tool? So you can see here that is directly plugged to the ISP connector, and from here some header, flat cable and header are coming out. These flat cables are bringing ground lines together with data lines. All the data lines here, the DIOs coming out from the FlashRunner, are twisted with ground lines. You have to do what our customer needs to do is that once the flat cable is reaching our header, that will be the object that is interfacing to the ISP target, from that point on, the wiring should be also at least fine and short, so that the job of the flat cable won't be lost. Because you can imagine having here guaranteed signal integrity and stability with the ground lines twisted to the data lines, but then maybe you have 3 meters of wiring, and then you are losing all the job that this tool is doing to your programming system. About advanced features that our FlashRunner is providing to our customer, we can quote, for example, the serial numbering, which is a way to serialize your boards. Every channel of the FlashRunner has a dynamic memory in which you can set up dynamic data. In runtime, during the programming command, all the target connected to the different channel will be programmed with the different dynamic data you have set up on the different dynamic memory of the different channel. So you can imagine a panel of 8 boards, every board connected to the 8th channel. In every dynamic memory of the channel, you set different data. In runtime, this different data will be programmed inside the 8 targets. We have cybersecurity commands to encrypt your firmware. During the FRB creation, we can generate an FRS, which is FlashRunner security, and this is done to protect your intellectual property. We will see it later. And then other advanced features, for example, conditional scripting to skip erase commands during the production to not waste time for virgin board and so on. About cybersecurity, first of all, we heard that in 2027 there will be a European law which is going to restrict even more the cybersecurity target side. That means microcontroller side, and this for sure will be also influencing the white goods sector. We already know that the automotive sector has already some restriction in the cybersecurity. In fact, we developed different cybersecurity levels on our system to provide more complex or less complex algorithm of encryption. In fact, for the white good, we didn't have such a restriction, but from 2027, this will be microcontroller side, so even the white good sector will be influenced by this. From our point of view, what we do to support cybersecurity microcontroller side is we guarantee OTP fuses, permanently debug port locking, lock and unlock process using password, managing of HSM, HSC when present in the devices, hardware security module, hardware security engine, and also feature to protect memory regions when available. All of these under specification, of course, and when the microcontrollers allows to be implemented. From FlashRunner side, we have the already mentioned encryption of your firmware file. So the FRB will not be anymore FRB, but will be FRS. You can choose to keep the data clear, so FRB file, or to encrypt your data and generate an FRS. This will not impact the flashing time or the programming cycle, and the only way to decrypt the FRS is in runtime during the programming command. So you will have the FRS, the encrypted version of your firmware file stored into your PC and also stored into the SD card, and only that FlashRunner is allowed to decrypt this file during the programming command and program your memory with actually the clear data. As I was saying, we support different level of encryption, from the most complex ones that allows you to generate an FRS which has the most advanced encrypted algorithm, from the less complex, which still gives a way to protect your intellectual property, but of course the process to encrypt is is more simple. We also have the way to encrypt the dynamic data, the ones that you can set into the different channels. So we can both encrypt the FRB, FRS called static data, and also the dynamic data that are the one you can set into the channels. We have integrity checks to all the resources that we use to flash your target devices. So we have CRC32 check on FRB file, project file, and any other file you use for the flashing. And this is another aspect we introduced recently. So from another point of view, we allow the access to our FlashRunner with a two-level access, admin and guest. And you can imagine already the admin is the one that has the full access to the FlashRunner features, so he can run project, get data, send data, alterate data, upload, and he can do anything. And then we have the guest access that is restricted by the admin. So basically here, maybe from the graphical user interface it is better to see. Here you can set a password. Let's say I will set a password. Okay. And now I'm logged as an admin, and I can choose the permission that the guest will do. So basically clear log, all these features, you can choose what to do and what to not to do. When I'm logged as a guest, for example, here you can see I cannot anymore transfer or get file from the FlashRunner. Then when I log again as an admin, I can get file from the FlashRunner and send file. So this is a way to restrict the usage of a FlashRunner. For example, some companies give the FlashRunner to third-party companies to manufacture their boards, and they want to limit the operation that this other company will do on that FlashRunner. And in the same way, you can also control the flashing cycle of this company.